Hi everyone, in this video we'll go through integration by parts. Integration by parts. This particular method is used when we have product of two functions. For example, you have function u and function v. You have product of two functions. For example, say you have x into e to the power x or x into cos x. So you have two functions here, right? So when you have such functions, how do you integrate? How do you find the integral? So for that, there is a theorem. Theorem states that if there are two functions, say u and v, and both are functions of x, integral of the product of these two functions would be u into integral of v minus integral of derivative of u into integral of v. And we'll have to take integral of this entire result. Alternatively, an easier way to remember would be consider u to be the first function and v to be the second function. So the theorem would be first function into integral of second function minus integral of derivative of first function into integral of second function. So one clue here is the second function will always have an integral. It's always going to be an integral of second function here and here. You notice this? It's integral of second function here, integral of second function here. And in this part, it's first function as it is. You copy the first function. And in this part, take the derivative of the first function. And once you get the result, the entire thing, you'll have to again find the integral. Now, how do you choose the first function and second function? So first, choose the functions in this particular order. Late, logarithmic, algebraic, trigonometric, exponential. For example, if you have logarithmic and algebraic together, then take logarithmic function as first function and algebraic function as the second function. Now, there is the proof for this particular theorem. So what we do is, we need to find integral of this product, right? Let's assume that the functions are u and w. Let's assume that these two are the functions. Now we need to find the integral of uw, right? This is what we need to find. But what we are going to do is, first we are going to differentiate u and w, right? We are going to differentiate. When you differentiate two functions, what is the formula? It is d by dx of these two functions is equal to first function into derivative of second function and second function into derivative of first function. Now, once you do this, you integrate on both sides. Integrate on both sides with respect to x. So, I'll put an integration symbol here. For this and for this, there's going to be integration. Now, what is integral of derivative of uw? Integral of derivative of uw is going to be uw itself. Because integral and derivative are going to give the function back. Because if I find the derivative of the function, and then take the integral of that function, I'll get the function itself. What is the function here? uw. That is what is integration, right? Integration is a reverse process of differentiation. So if I differentiate this and then integrate this, I'll get the function back, which is uw in this case. Here I'll get u into dw by dx. I'm just putting integral symbols here, right? Now, what we will do is, we don't know what this dw by dx is, right? We don't know. Nor do we know what is du by dx. So what we'll do is, we'll assume that this entire dw by dx is v. Then we integrate this. So when I integrate dw by dx, again it's going to be reverse process. Integral of derivative, I'll get the function itself. So I'll get w here. Integral of dw by dx with respect to dx, it's going to give me the function itself. What is that? I'll get w. W is equal to integral of v into dx. Now what I'll do, I'll substitute this w in this equation. Instead of w, we'll substitute what we obtained here. We'll substitute this in this particular equation. So we have u into w, and instead of w, we'll put v into dx. Instead of w, we'll put v into dx is equal to, what is dw by dx and dx? This entire thing, which is here, is nothing but integral of v into dx. So you substitute. It's nothing but integral of u into v into dx. Then plus, here again, wherever w is there and wherever dw is there, we actually substitute. So integral of du by dx will leave as is, and instead of w, we'll put integral of v dx here. That's all. Now, what we will do is, we'll rearrange. We'll bring this here, because we need to find integral of uv, right? These are the functions for us. We'll have to find the integral of these two functions. So I'll get this on the other side, and I'll take this on this side. So when I get this to this side, and this portion to this side, I'll get this particular expression. Now let's solve few problems. Let's take this example where we have to find integral of x into e to the power x. So there are two functions here, right? X and e to the power x. Now, how do we choose the first function? We have one exponential function and one algebraic. This is algebraic and this is exponential. Exponential is any function that has power, right? So now we'll have to choose algebraic before exponential. Late. Use this rule. Late. Logarithmic, algebraic, trigonometric, and exponential. So exponential is coming in the last. Algebraic is coming before that. So take algebraic as the first function. And another clue is always take the function for which you know the derivative. The first function that you pick up, you should be knowing the derivative of it, right? Now, in many cases, you would know the derivative of both the functions, right? But this is one clue. So we choose x as first function and e to the power x as second function. Now we'll use the formula. What is it? Integral of x into e to the power x dx is equal to, we'll take first function, just copy first function as is, which is x into integral of second function, which is e to the power x, minus, always have this big integral because we have to find the integral of this entire expression. And within this, you have to find the derivative of first function. Always remember, the derivative is of the first function. First function is x into integral of second function. This one, we'll just copy this, right? Integral of second function. Just copy this and dx. Now, what is integral of e to the power x? It's e to the power x itself. What is derivative of x? It's 1. What is integral of e to the power x? E to the power x itself, right? And then dx. Now, this is nothing but, what is integral of e to the power x? E to the power x itself. And then we'll have to put this c. Let's not forget this constant. So, this is the answer. Now, let's take another example. Let's find integral of x into sine x. X into sine x. So, again, what is the order? What is the late rule? First should be algebraic and we have sine x, which is trigonometric. So, algebraic should be first function. So, let this be first function and this be second function. So, let's apply the theorem. First function, copy first function as is. First function into integral of second function. It's always integral of the second function. Remember that. Second function is sine x minus the big integral. Let's open the brackets. Derivative of first function. It's always the derivative of first function. That is derivative of x into integral of sine x. Let's copy this as is. And then dx. Now, what is integral of sine x? It's minus cos x. What is derivative of x? It's 1. What is integral of sine x? Minus cos x dx. Now, we need to find the integral of this entire thing. So, let's copy this as is. Minus x cos x minus, let's bring minus to the other side. So, it becomes plus. And what is integral of cos x? It's sine x and plus c. So, this is the answer. Now, let's take this particular example. We need to find the integral of x into secant square x. This will be the first function and this will be second function because this is trigonometric and this is algebraic. So now let's use the theorem. Let's copy the first function, which is x into integral of second function, which is secant square x dx, minus integral, open the brackets, derivative of first function, which is x into integral of second function. Let's copy this as is, secant square x dx. So, what is integral of secant square x? It is tan x. Minus, what is derivative of x? It is 1 into integral of secant square x, which is tan x dx. So, x tan x minus, what is integral of tan x? It's log of secant x plus c. So, this is the answer. Similarly, let's take this particular problem. Same as the earlier problem. Here we have cosec square. Earlier we had secant square. Now we have cosec square. Again, we take x as first function, cosec as second function. You take first function into integral of second function, which is cosec square. Big integral, derivative of first function, which is x. And then into integral of second function, which is cosec square x. And then dx. So integral of cosec square is minus cot x. And derivative of x is 1. And integral of cosec square is minus cot x. Now, let's remember one thing. Integral of cot x is log sin x. We need to remember this. We bring the minus out, so it becomes plus log of sin x plus c. So this is the answer. Let's take another example. We need to find integral of x into sine of 5x plus 7 dx. Now here again, we'll choose x as first function and sine as second function. First function and second function. So copy the first function as is. Take the integral of second function. That is integral of this function. What is integral of sine? It's minus cos. And copy this expression as is, 5x plus 7, and divide by the coefficient of x. What is coefficient of x? 5. Divide by coefficient of x, which is 5. Minus big integral into derivative of first function. Derivative of this function. Derivative of x is 1. Into, copy this entire thing, integral of second function. This is integral of second function. Integral of second function. Copy this as is. Now, we'll just simplify this. Minus and minus becomes plus. Now, what is integral of cos? It is sine. And copy this entire expression as is. And we have 5 already. Now, copy this coefficient. Copy this coefficient and put it in the denominator. So, it will be 5 into 5, which is 25. So, this is the answer. Now, let's look at this particular problem. X into e to the power 3x plus 5. So, again, this will be first function. This will be second function. Right? So, it's similar to the earlier problem, except that here, integral of e to the power 3x is e to the power 3x itself. You'll have to copy the coefficient. You have to copy the coefficient in the denominator like this. So, we'll have to remember that always the coefficient of x should be put in the denominator. That's all. Let's take this another problem. Let's try to solve this. So, here, we'll take this as first function and this as second function. So, we'll have to put first function into integral of second function minus big integral derivative of first function into integral of second function, open the brackets, and dx. So which is going to be the first function here? It's going to be log. So based on the rule late, right? Logarithm function comes first and algebraic comes later. So that way this becomes first and this becomes second. So first function is log x. So log x, the whole square into integral of second function, which is x, minus big integral, derivative of first function, derivative of log x. So what is the derivative of log x, the whole square? We'll have to apply chain rule. First, we need to find the derivative of this power. So it will be using the formula, derivative of x to the power n is n into x to the power n minus 1. So we have square here. So 2 into, instead of x, we have log x to the power n minus 1, that is 2 minus 1, which is 1. And using chain rule, we have to find derivative of log x. What is derivative of log x? It's 1 by x into integral of second function, that is x. What is integral of x? It's x square by 2. You have to increment the power, right, when you're finding integral, and dx. Here also, we'll have to put integral of x, which is x square by 2. So we're going to get x square into log x, the whole square, by 2 minus 2 and 2 will get cancelled. 1x and 1x will get cancelled. So we'll get x into log x. Now again we'll have to use this particular theorem. Use the theorem again, because again we have product of two functions, right? This will be first function, this will be second function. Now we'll do this again. So let's copy this, minus, so again we'll put a bracket here. First function is log x. Log x should be the first function because logarithmic function should come first compared to algebraic function. So log x into integral of second function. What is integral of second function? X square by 2 minus big integral, open the brackets, derivative of first function. Derivative of log x is 1 by x into integral of second function. Second function is x, this one, right? So integral of x is x square by 2. Basically we copy this and dx. So we get, let me copy the whole thing. We get x square by 2 into log x minus x and x will get cancelled. So I'll be left with x by 2. Let's bring half outside. So it's going to be integral of x. Half is going to come outside. Integral of x. Integral of x is x square by 2 and plus c. Now we'll simplify this. So this is going to be x square by 2 log x, minus and minus is going to be plus 1 by 4 x square plus c. So this is the final answer. Let's take this another example. Let's try to solve this. Here we have integral of 1 by x square into log x. So this will be the first function and this will be second function, because logarithmic function comes before algebraic function. So this will be first function, which is log x into integral of second function, which is 1 by x square, minus big integral, open the brackets, derivative of first function, which is log x, derivative of log x is 1 by x, into integral of second function and dx. Now this will be log x. What is integral of 1 by x square? I can write 1 by x square as x to the power minus 2. I can write it like this. I can take x to the top, right? I can take x to the numerator and use this formula, which is integral of x to the power n is x to the power n plus 1 by n plus 1. So now we'll use that formula. So it will be x to the power of minus 2 plus 1 by minus 2 plus 1 minus 1 by x. Copy this. X to the power of minus 2 plus 1 is minus 1 by minus 1 and dx. So what do we get? We'll get log x, x to the power of minus 1 by minus 1 minus integral of this. So if I take this on top, it's going to be x to the power of minus 1. And already have x to the power of minus 1. Let's bring this minus outside. So when I bring minus outside, minus and minus will become plus. I'll get this. So this will be minus log x. I can bring x down. So when I get x down, minus 1 will become plus 1. Plus, this will become integral of x to the power minus 1 will become minus 2. Now let's integrate this. I'll increment the power. So it will be x to the power minus 2 plus 1 by minus 2 plus 1 plus c minus log x by x. So this is nothing but minus log x by x plus x to the power minus 1 by minus 1 plus c. Now let's rearrange this. So it will be minus log x by x minus, I'll bring x down. So when I get x down, the negative power will become positive power. So it will be x to the power 1, which is x, plus c. So this is the answer. So with this, we've come to the end of this particular topic. If you have liked this video, do press a like and share it. Thank you.